It's just a little bit of a different format. It's JSON format versus the HTTP format here. And then the third one shows an example of doing a range query on the post date and then giving it dates that Elasticsearch can do the range query between. Just a couple, just a quick, kind of quick example. This is an example of putting in a document, and here we're doing an HTTP GET. Twitter, again, is the index, tweet is the type, and the ID is 2 in this case, so we'll pull that document back for you directly. So basic hits and puts. And then just a little bit about schema mapping. This is just a really, the first one, if you just do a put to that index, it will create a schema, but or create an index, but it's just an empty schema for you. The second one's just a very small example. You know, we're expecting a type of name, which is going to be a string value. There's a bunch of other parameters that you can add, you know, to specify, you know, analyzers for search and for querying, and a bunch of things like that. You can get really quite complex schemas if you need to, and even if you have a defined schema for an index or type, by default, Elasticsearch will continue to modify your schema. You know, let's say if I packed in a document that had a user and some other fields, Elasticsearch will accept that, and it will modify your mapping for you by default. You can tell it, you know, you can disable that feature if you want to kind of tighten your mapping down for you, or tighten your mapping down. And in that case, if you try to index a document with extra fields, Elasticsearch will throw an error to say, you know, look, you put some stuff in here that I'm not expecting. So kind of a neat thing that you can do with this, I don't know how many are familiar, but you can sort of, with this kind of a setup, you can sort of upgrade your schema on the fly, right? So if we started like this and all of a sudden we have a requirement to add new fields to our schema, which never happens, except all the time, then you can either add new fields to the schema and update it, or just throw the document in Elasticsearch and it will pull it in and start creating all those new fields. And then as your application updates the previous documents, it will continue, you know, it will continue to work. So you can have sort of an in-fly, you know, on-the-fly updating of your schema. So it's multi-tenancy as well out of the off the bat, which we talked a little bit about. You can specify multiple indexes. You can specify multiple types for indexes. So it can be very flexible in how you know, you index your data, how you can then use that in your search queries to find, you know, what you're looking for. So just kind of a note on this as well. I was talking with a guy this last summer about, he was having a little bit of problem understanding Elasticsearch because he would form queries and it would give him back things that he didn't expect. It's like, well, what do you? It's like it's not like a database. If I do a query for the database and it doesn't have anything, it won't give me anything back. But Elasticsearch will. I said, right. It's a search engine. It's based on, you know, you got to think differently. It's based on finding things. It's based on findability. And so it can be, you can make it very exact if you wanted to, but it can be very inexact, which can be a very good thing. I mean, if you have a corporate search engine and somebody's looking for something and they type in a query and nothing comes back, the user's going to leave the site because you just told the user, I don't have anything interesting for you, right? You said go, you just said go away. Of course, that's kind of a double-edged sword. If you give back the user something that's completely irrelevant, they're going to think, you know, your site is dumb. You're not doing anything. You're still not helping. Go ahead.
Can you? I see here you're doing a query via GET. Is there a way to do it? Yeah, with a post with a payload in the body, so you don't have to worry about the limit on the GET, you know, on HTTP GET.
Yeah, absolutely.
Okay. And if we're going to get to that, I don't want you to rush ahead.
Yeah, no, this is going back a little bit. You can see at the top is a GET, and this, well, it says GET there.
Oh,
because it's pulling back. But it does post as well. This again in this case.
And I think,
It's not-
am I right or wrong that Solar doesn't support that? Solar's get only for queries?
I believe so, because I believe Solar uses URL parameters
Yeah.
to form your queries, and so it ends up being, generally speaking, probably a lot less flexible, especially if you have a complex schema. And so, and also with the JSON, you know, it's a lot more readable. You can format it and make that stuff. ElasticSearch also will have support for parent-child documents. So it's you know, underneath it does some tricks to make it work, because it still ends up getting flattened out. But it ends up giving you some very interesting possibilities that I think you can replicate on Solar, but it becomes a little bit more difficult. The interface here is quite a bit easier. So for example, like if you wanted to do a query and pass it on all the children, right?
Yeah.
You can do that actually quite easily. So a little bit about the architecture of ElasticSearch. It's distributed by nature. I'll show you a little demo here. So it breaks all the data into shards. So in each shard is a fully complete leucine index. If you guys understand anything about leucine, so it exists on its own. When you create an index, you specify the number of shards, which is how it's going to break up your data. And generally, the more shards, and as you add more machines, the shards get spread over machines. It can increase your write scalability. Replicas are copies. One replica is one copy of all of your shard set. So by default, ElasticSearch, if you don't specify, it will create an index with 5 shards and 1 replica. And it will not put all the replicas on the same machine as, essentially calls it the master set of shards. So if you specify, 1 replica, which means my master copy of the data plus 1 copy of the data, you'll only get 1 set of shards until you add a second machine. Then what it will do is it will put 1 copy of all your data on 1 machine, and it will put the second copy on the second machine. So you have 2 identical copies. And the nice thing is that it's not a master-slave environment. So any node can answer any query. And if it doesn't have the data, it will proxy the query across the other nodes for you, which can be quite nice. So if you specify the schema with 5 shards and no replicas, and you add a second machine, you'll end up getting 3 shards on 1 machine and 2 shards on the other machine. And then it will. I have a little video that kind of shows how that works. And then the underlying Leucine engine, each shard or Leucine index is broken into segments, which are kind of extensions. So essentially, if you're doing a lot of really heavy indexing, once the shard gets too big, it has to compact it, because you only specify a limited amount. But what it does is to keep write performance up, is it will create additional segments until it gets to a limit that you tell it, say like 30 segments. And then once it gets to 30 segments, it'll have a compaction phase, so your indexing will slow down while it's doing the compaction, and then it will keep doing this kind of effect. It also has routing ability, which is a way to tell ElasticSearch that you only want to look at specific shards in your data. Okay, so for example, if I have 5 shards and I do a query, all the queries are scatter-gather. So it will query all 5 shards, it will get the results and merge them and give them back to you. And it works really well. If you have a lot of data and you have a lot of shards, it takes a lot longer to be able to do that. So what you could do is you can give ElasticSearch essentially a hint when you're indexing your data and when you're reading your data to say, based on this piece of information, this is where I want you to end up putting my data, or putting it in the index. And so, for example, the nice thing about it is instead of if you've got 100 shards, you can get it so the ElasticSearch will only search that one shard that you're certain that data is on and give